Dear students, today we discuss the loss of energy on contact of two capacitors. We know well that the capacitor is an electrical device which stores the electrical energy. It has two plates separated by some distance. When the positive charge is given to one plate, when the another plate is brought near, the charge carriers are created on the other plate. When the positive charged plate is brought near the neutral plate, a positive and negative charges created in the neutral plate. The positive charges in the neutral plate are earth. So the positive charges in the plate A and the negative charges in the plate B is formed. Here the question is, prove there is a loss of energy of charges during the contact of two capacitors. For this, consider two capacitors C1 and C2. The charge to a potential V1 and V2. It is the first capacitor. Its capacitance is C1 and it is charged with the potential V1. So the positive charges are charged here and the negative charges are charged here. There is a plus Q and a minus Q. The two plates are separated by a distance small d. Another capacitor or the capacitance C2 is charged with the potential V2. The potential V2 is lesser than the potential V1. So less charges are present in the plate A and the plate B of the second capacitor charged with the potential V2. Now we are joining these two capacitors with a wire. On joining these two capacitors, we know that it is the first capacitor is under higher potential, the second capacitor is under lower potential. Now they are joined by a wire. What happened when we join by the wire? So a common potential is created between these two capacitors. It is indicated by capital V. So the total potential V is equal to total charge divided by total capacitance. See here, these two capacitors are joined by the wire. So the common potential created here is capital V. So the V is equal to C1 V1 plus C2 V2 by C1 plus C2. Here the total energy, it is a potential. Here the total energy of two capacitors before contact. Before giving the contact, V1 is equal to half C1 V1 square plus half C2 V2 square. The total energy of the two capacitors after connecting by a wire or after contact is given by V2. It is a before contact potential, the total energy. It is after contact total energy. So we have of C1 C2 into C1 V1 plus C2 V2 by C1 plus C2 whole square. On simplifying, we will have so C1 plus C2 and this one gets cancelled. So the loss of energy due to contact of two capacitors is V1 minus V2. So it is before contact and it is after contact. So we are subtracting these two. We have 1 by 2 C1 plus C2 into C1 plus C2 C1 V1 square plus C1 plus C2 C2 V2 square minus this value. This common term is taken out. It is 1 by to C1 plus C2. So it is C1 plus C2 into C1 V1 square plus C2 V2 square minus of C1 V1 plus C2 V2 whole square. So this term is multiplied initially by this one. So C1 square V1 square, and then here C1 C2 V2 square. Next, this term is multiplied with this. So C1 C2 V1 square plus C2 square into V2 square. See here. And this term is expanded. A plus B whole square formula. A square plus B square plus 2AB. So C1 square V1 square plus C2 square V2 square plus 2AB. 2C1 C2 V1 V2. On simplifying, C1 square V1 square, this one gets cancelled. On C2 square V2 square and C2 square V2 square gets cancelled. The remaining terms are written here. Here the C1 C2 is common term, so taken out. So C1 C2 by 2 into C1 plus C2 into V1 square plus V2 square minus 2V1 V2. It is nothing but A minus B whole square formula. It is A square plus B square minus 2AB. So this term V1 square plus V2 square minus 2V1 V2 is modified into V1 minus V2 whole square. From this equation, it is of C1 C2 by C1 plus C2 into V1 minus V2 whole square. Due to this negative term, it is proved that there is a loss of energy due to contact of two capacitors. There is a definite loss of energy during the contact of two capacitors.